Numbers, statistics, data. Government and businesses spend billions of dollars each year collecting, analyzing, and storing it. Data is the speedometer of commerce, government, and healthcare. It informs management how their enterprise is doing. Understanding data, then, is crucial. And while math is the process used in manipulating data, there is art in its interpretation. And visualizing data is a powerful companion to its analysis. Edward Tufte took data visualization to the level of high art by showing the difference between presenting data in bar and pie charts and showing dynamic relationships in a way that fosters understanding of what the data represents and means. Tufte has cited the work of Charles Joseph Minard as the best example of a statistical chart ever drawn. Minard, a French civil engineer, used data of Napoleon's army as it moved against Russia in 1812. The data on soldiers and food and killed in battles and temperature was well documented by Napoleon's quartermasters, and the numbers are mind-numbing, until they were woven together to tell the story in visual terms that showed the scope and drama of the war. In Minard's chart, we see the accumulation of soldiers and resources on the journey to war, and the devastating losses in their return. You can see the diffusion of energy and purpose in Napoleon's failed conquest. Today, we are overwhelmed by data, as computers capture ever more discrete elements of daily life. Gas pumped, electricity consumed, foods purchased, cars and houses sold, unemployment rates, stock performance. The numbers easily overwhelm our ability to differentiate and focus. At the University of Texas in Austin, a team of scientists and engineers are extending the work of Edward Tufte to represent gargantuan amounts of data in ways that help businesses, healthcare workers, and lawmakers to understand what the numbers mean. Paul Navratil, a visualization scientist at the Texas Advanced Computing Center, is working with graduate students and others in pioneering the next generation of digital visualization, where the video wall is an important tool in the process of understanding what the data means.
Well, the simplest way you could say it is we're making a picture out of numbers. If you've ever made a pie chart in Excel, you too have done visualization. And if you've seen the weather report at night, that also is visualization. These instruments that we use, the computers and physical instruments, give us this stream of data, and it's usually ones and zeros because that's what computers use. But humans aren't really good at processing that. We use about 80% of our information we gain through our eyes. And so we use visualization to transform this data into a form where we can use our most powerful organ to interpret it. Because that's the second element of a visualization, is not only does it have to convey the information, it needs to do so persuasively.
Instant magnification combined with very dense visual detail allows a user to move from the macro to the micro view. From the exploration of the universe in our Milky Way, to the surface of the moon, to the analysis of hurricanes and the spread of viruses, to the molecular structure of a virus, we see the complex world in a more refined, simpler way that helps us to understand the dynamic relationships between geography and history, time and resources, and facts and meaning. Reporting from Austin, Texas, I'm Jeffrey Iavecchia.